Hello friends. Now in this class we are going to discuss about root mean square velocity of a gas particle by using Maxwell's velocity distribution formula. In this deduction we assume the velocity of the particle is c and the equation of Maxwell's velocity distribution formula in a spherical polar coordinate system. We have already deduced Maxwell's velocity distribution formula in a spherical polar coordinate system that we can write here dn equal to 4 pi n m by 2 pi kt to the power 3 by 2 multiplied by e to the power minus mc square by 2 kt to c square dc. This is the equation of Maxwell's velocity distribution formula in a spherical polar coordinate system. Now we have to deduce the root mean square velocity of a gas particle. For that, suppose we have the velocity c of gas particle and we have to calculate root mean square velocity. That means this is the square of velocity c square and then we take the root of this square velocity and here we take the mean of the square velocity. Then we have to calculate first of all the mean of the square velocity and then we take the root of both sides, then we can get the root mean square velocity of a gas particle. Okay, so let us start. So we have already deduced Maxwell's velocity distribution formula in a spherical polar coordinate system in between the velocity c to c plus bc. This is the velocity. In between that we have calculated the Maxwell's velocity distribution formula. So we use that formula and get the Maxwell's velocity distribution. By using Maxwell's velocity distribution formula, we get the root mean square velocity of a gas particle. So first of all, we calculate mean square velocity. Mean square, this is the mean square velocity. That means we take the total number of particles, means summation of the dn. Summation of dn, and with this total number of particles we multiply the square velocity, then we get total number of particles which are moving with the square velocity. Then we multiply c square and then divided by summation of dn. Then this is the average value and this average value is called mean square velocity of a gas particle. Then we take this value here and same value here also. So we can write summation over summation of this value 4 pi n m by 2 pi kt to the power 3 by 2 e to the power minus mc square by 2 kt into c square dc. This is the value multiplied by c square. This and divided by summation of 4 pi m by 2 pi kt to the power 3 by 2 into e to the power minus mc square divided by 2 kt into c square dc. Okay. Here we are going to calculate in that these are the fixed values and this is also fixed values. So we can take out of the summation. This also we can take out of the summation. And then we convert it into integral. Or before that also we can convert it integral, and before integrating these values we take out of the integral and then we can calculate. So we take out this and then we can write, and after taking out of from the integral, these two values we can cancel out and then we can write integral from 0 to infinity, because we have to calculate only positive values, only positive velocity, the number of particles which are moving with positive velocity, because in between c to c plus dc they have only positive values. So we can take the limit from 0 to infinity e to the power minus mc square by 2 kt into c square dc divided by integral from 0 to infinity e to the power minus mc square divided by 2 kt into c square dc. So now we have to calculate by using these terms. Okay. So now I am going to erase the upper terms. So now you will start to calculate this integral. Suppose here in this case, if we take m by 2 kt as alpha, now put m by 2 kt equal to alpha. So mean square velocity is equal to integral from 0 to infinity e to the power minus alpha c square into c square dc divided by integral from 0 to infinity e to the power minus alpha c square c to the power 4. Here it is c to the power 4. Here this is c to the power, here c to the power 4. Here c to the power 4 alpha c square into c square dc. So this term see here, this is like a standard integral. So we use this standard integral and we can write the direct values of that standard integral. So by using a standard integral, now using a standard integral, what is this? This is 0 to infinity e to the power minus alpha c square into c to the power 4 dc. This is one term, and the other term is from 0 to infinity e to the power minus alpha c square into c square dc. These two are the standard integral. So what is the value of these standard integral? What are the values? What are the values? Think about that. What is the value of this standard integral and this standard integral? Here this standard integral have the value here, see, from 0 to infinity e to the power minus alpha c square dc. So for this we can write the value 1 by 4 root under pi by alpha to the power cube. And here this is c to the power 4. These other terms are same. But here instead of c square, here it is written c to the power 4. Then this value will be 3 by 8 into root under pi by alpha to the power 5. Now we use these values here. So mean square velocity is, this is c to the power 4 terms, this 3 by 8 root under pi by alpha to the power 5 divided by 1 by 4 root under pi by alpha to the power cube. So pi cancel out, and this 4 2 is 8. Okay, then 3 by 2 and alpha to the power 3 alpha to the power 5, then we can get alpha square, and we take out of this square root, we write 1 by alpha, then we can write 3 by 2 into alpha. Okay, 3 by 2 into alpha. Then we put the value of alpha, 3 by 2 into value of alpha is m by 2 kt. Then we can write m divided by 2 kt. Then we can write, then this 2 cancel out. Then we can write 3 kt by m. 3 kt by m. Okay, this is the value of mean square velocity. Okay. Now we write offside. So mean square velocity is equal to 3 kt by m. Now we take the square root of both sides, then we write it as root mean square velocity 3 kt by m, and this is CRMS, means root mean square velocity. This is the root mean square velocity of a gas particle. By this way, we can calculate the root mean square velocity of a gas particle. So, we have calculated root mean square velocity of a gas particle by using Maxwell's velocity distribution formula. In next class, we calculate one more deduction, mean square velocity of a gas particle. So you just try it, and then in next class we calculate mean square velocity of a gas particle by using Maxwell's velocity distribution formula. Thanks for your attention.